I guess I need to ask for a thumbs up too, because hopefully everybody can hear us. The silent thing is great if you're in the audience. Up here, we just talk to ourselves. So thank you so much for joining this session on the future of Earth observation. My name's Aaron Addison. I'm the executive director of the World Geospatial Council, and it's my privilege to be able to work with these professionals and leaders in their respective fields in and around the topic of geospatial. So really looking forward to our discussion today and learning a little bit more about what's on their mind and what their thinking is as we look forward. There's no doubt that the pace of change for Earth observation is accelerating, shows no signs of slowing. And so I think this is a very timely conversation, very important conversation to start having, because by the time these things happen, it'll be far too late to react to them, of course. And that's not just a technical conversation. So today we'll also learn people are starting to think about what is an authentic image? How does that work in the age of AI? Can I trust this map? And so forth. So, topics that maybe haven't been there in the past, like chain of custody, start to become top of mind as decisions are being made based on this data. But before we get to that, I want to give each one of our panelists a chance to introduce themselves and say a little something about their company and where they're from. So I'm going to ask to my left here, Bo, to kick us off from Esri. Bo.
Yeah, thanks, Aaron. Yeah, hi everyone. My name is Bo Laguerre. I'm the Director of Imaging and Remote Sensing at Esri. Esri is a global leader in mapping, GIS, and location analysis. And my role at Esri is to bring the power of imaging and remote sensing to the GIS user base, to show the mapping community, the community that is trying to solve problems based on location, the value of Earth observation data, general imaging and remote sensing content, whether it be from space, drones, aerial, or ground-based sensors. So my group thinks a lot about how these emerging sources from Earth observation can impact everyday use of GIS and how we can expand the utility of these sensors into the commercial markets as well as public sector markets. So yeah, thanks for having me on the panel.
Great, thanks, Bo. Alina, you're next.
For EOMAP, a Fugu company. I work as a geospatial data analyst, and we are specialized on using Earth observation data to monitor different environmental systems. So we're basically focusing on water systems. So we have two main branches. One of them is the water quality applications. So we do track water bodies, mainly inland bodies, and track the water quality parameters based on mainly multispectral satellite data. And the second branch will be the coastal applications. So we basically can use satellite data, again, mainly multispectral data, but also different sorts of data, to derive the bathymetry, so the depth of coastal waters, to map benthic habitats in those coastal waters, and also to derive coastal dynamics. And we have a wide customer range that range from government and research, but also environmental agencies. We do have coastal engineering companies, but also the energy sector that use our data.
Perfect, thanks, Elena, welcome. Simone.
Hello, my name is Simone Gianecchini, longest last name ever, I know. I work at GeoSolutions. We are a software house basically, and we develop a number of open source solutions for the geospatial. The most widely known, I would say, is GeoServer. Maybe you've come across it. We actually started in remote sensing like probably 20 years ago, because we were working for a NATO center in Italy, in a data fusion center, let's call it like that, when satellite data was actually purchased by emails and PDFs, etc., etc. So, I mean, where we have arrived from there, it's pretty astonishing. But anyway, we have evolved a lot since then, and we work in a lot of different domains nowadays, because what we do is horizontal to many different domains. We still have a quite decent number of customers in Earth observation, and that's a traditional Earth observation, but as we were discussing the other day, Earth observation like outside the traditional way, so many different ways to acquire data looking at the Earth, like aerial imagery, drones, etc., etc. And also I would say meteorological data, which is starting to cross domain a little bit with Earth observation. Thank you.
Perfect. Will.
Will Caddell. I run a company called Spark Geo. We build custom geospatial software applications. Historically, we've done that for the US tech sector, but now we sort of spread our wings and build cloud-native geospatial data distribution, data storage solutions for governments, for Earth observation companies, really wherever data is being acquired and then redistributed. Our team is in the most part in Canada, but we also have a small team in the UK and in the US too.
Perfect. And rounding out our panel is Max.
Thank you very much. My name is Max. I'm co-founder and CEO of Wingtra. We offer our clients really the true drone surveying solution. So it's the data acquisition piece on the drone, but then all the way including the processing to get to orthophotos and point clouds of hundreds of hectares at a centimeter level. So I think we are really marrying, when we zoom out a little bit and we look at Earth observation as a whole, there is terrestrial GNSS and there are satellites, and in between we have drones, and they can take some of the best of both worlds, right? On one hand, we get accuracy and timeliness of terrestrial GPS with the scalability, or some part of the scalability of what we see in manned aviation or satellites. We have about 1,800 customers around the world, have been in the industry for 10 years, and I'm super excited to be here today on the panel.
Welcome, Max. That's a great segue. I think sometimes when people think about Earth observation, they think about only satellite imagery. And in fact, anything between the Earth and space is still Earth observation, whether we're talking about traditional survey, LiDAR, drones, upper atmosphere devices, or low Earth orbit. And that's, I'm happy to say, is starting to expand the definition of what it means, but it also then sort of expands the definition of what the future of Earth observation means. And we're talking about future of Earth observation in the title of the panel today. I think one of the things that the audience might benefit from your knowledge, each of you, is that there's so much going on. How do I separate signal to noise? What's real, what's not real? Like, what are the things that each of you are tracking right now as you look out towards the future of Earth observation? And is that something that you see in a year? Or is that still 5 years out? We can all agree that nobody says, I wish I had less data. Can you give me lower resolution? Nobody ever says those kinds of things, but what does that mean? And is that really fit for purpose? Is that really the data that I need in order to answer the questions that I'm asking? So I'm going to start right in the middle with Simone, and then we'll jump around on our panel here.
Okay, that's a very interesting question. Many things that comes to my mind. I mean, the one thing that I noticed lately that is interesting for me, because we have customers that are like, the German Space Agency is a customer, for example. So, Earth observation is central. And so, nothing is really new for them, because, multispectral data, SAR, etc., it's been there forever. But when you talk to different kind of perspective, like, for example, cities, and obviously I'm not talking about small cities, but cities like Florence, Helsinki, this level of cities, they're starting to ask questions about how we can use Earth observation data, etc. So, and this is interesting because it opens up a lot of opportunities also for companies, but also for seeing data that's being used for real. Because my experience with Earth observation for ages has been that there was a lot of data, but the problem was to understand what we do with it, if you see my point. And now it's people from the field that are starting to ask, can we use data to do this, to do that? Because obviously they hear about it, but they start to see the potential. Urban heat islands, floodings, and things like that. So fusing, obviously not using this data alone, fusing this data with obviously other sources of data, modeling, AI, whatever, but they're starting to ask, and this is relatively new for me. Okay, this is an interesting thing, I would say, at this moment. And
so there's some education that's in there too, to say, hey, here's what's possible, here's what
I can give you a very real example. The region of Tuscany where I live, it's just everybody is going to envy, etc., etc. But they were actually making this summer training for people in public administration, how to use Sentinel data, the Copernicus platform, etc., etc. Is this going to create anything immediately? Probably not, but it's a signal, if you see my point.
Yeah, absolutely. Will, what are your thoughts?
There's so many interesting things. I fear our community doesn't know what's going to happen when we're challenged with deepfakes. I think there's something that we need to deal with there, and I also I think the notion of tracking the provenance of an individual pixel is going to be absolutely key as we are in sort of more geopolitical and business environments with complexity attached. I think this notion of tracking the truth of a particular location is going to be pivotal. And I would argue that the remote sensing community has been somewhat obsessive over pixels as opposed to the location of those pixels. So the fusion of those two data products is going to become increasingly important. So which is, again, as an extension to that point, thinking about how data products can be robustly fused together using open standards, using sort of common understandings of geography, of time, and then finally thinking about what happens when we don't really need maps that are flat anymore. So how, like can we think of robust, discrete global systems, because now we can model things in non-flat environments, inside computing environments. Doesn't need to be flat, don't need spatial reference systems. Can we have a real, true sort of understanding of our planet's surface? Therefore, what does that mean from a processing perspective? What does that mean for our understanding of truth of the landscape?
Yeah, I think that's an interesting point, because for the first time, maybe even just in the last year or so, I've started to feel that we're moving out of the era of where paper's still king, where the flat map, for all that we talk about digitally, paper was still king. You know, it was still the final idea whenever you were producing a map. And now, you know, it feels like that's shifting, that's changing. And to your point,
yeah, I mean, I think we've still got a lot of screens around, so like you know, they're in the most part flat. But like we can model global things inside screens. But I'd also say mapping is becoming like a first-person activity. It's an augmented experience, and therefore, I think the more modern interfaces are device-based, but also like audio. My kids have got headsets on all the time. I've got a headset in most of the time. Like, what does the audio map look like? I think that's interesting.
Yeah, absolutely. What are you seeing, Max?
Yeah, I can totally relate to what Will was saying. Also on the traceability of individual pixels. Like, there's a lot of risk or things we need to manage. At the same time, I feel there is very mundane problems we had for a long time, and we still will cope with for a couple of years now. I think what was exciting this year at the show, I think it was the first time that I think the internet is at a level where it's stable enough. You can just get 40 gigabyte, 60 gigabyte of point cloud streamed at the booth, and it's actually starting to work. So this is great to see, because we have so much data. Usually it's like stuck into individual computers on hard drives. I mean, the whole thing will get so much more powerful when we can truly and easily collaborate. And there has been cloud solutions for a long time, but as long as the data products are so heavy and just basic internet speed is not working when I'm out there in the field or on a fair or doing these things, I think that is fundamental things that are getting better, and I hope they are getting better quickly, because they will spur so much more ubiquitousness. Can you say ubiquitousness? Whatever, like more, just having more of that around us every day. And then I think the other part is workflow, right? We have, when I think about it, there is data, information, insights, and actions ultimately. And what we want to manage our planet in a more sustainable and more efficient way, right? Manage our assets in a better way, natural assets and man-made or human-made assets. And to do that, we need to take the right decisions, the right actions. For that, we need insights. For that, we need information, which is structured data. But it's easy to produce a ton of data. It's not so easy to extract necessarily the information you need and then ultimately distill the insights and take the right action out of it. So I feel there's still a lot we can do, and what we try to do at Wingtra is always come from the final deliverable, the question the final client wants an answer to. And it's not easy to even ask the right question, right? Because we can push as much data and like point clouds and LiDAR point clouds or photogrammetry data there, but we need to know what are we after. And that is, we see it, we are a very horizontal platform, right? On the data capture piece, you don't necessarily, it's not different if I go into agriculture or construction, but the final questions these two clients might have can be drastically different. So we need to come from the ultimate beneficiary that is managing their assets and then work our way backwards. I think that's super important.
Yeah, I think that's a really important point because, you know, when I interact with companies in geospatial and Earth observation, and really this community here at INTERGEO, is that for everybody outside the walls of these halls, the map is not the end. The map is the beginning, right? It's only then can they start doing whatever they need to do or take a decision. And I think you're spot on with your comments around the foundations of even connectivity being a fundamental part and really the cornerstone of interoperability, because now you can start to look at things in a different way where they don't just have to be on hard drives, but they can be in, you know, as I heard it described earlier this year, it's not to have the cloud or not the cloud, but how many clouds, right? And so then you almost need a new term like omni-cloud or something to describe that architecture and what's happening there. Let's come back to this side and go to Alina.
Yeah, I totally agree with what you were saying. So I think we're seeing this trend of just having more and more data, right? So we're going into hyperspectral, we're going into higher spatial coverage, higher temporal coverage. So we have all this data, which is like, there's a high potential. But what we need to do is to manage this kind of data. So we need to make sure that the data is digestible for the people who are eventually going to use the data. So you need to understand what are their needs, what are they looking for, and then you need to get the appropriate data. You cannot just flood them with data because you know it's like state of the art and you want to like brag and show what you're able to do, but you need to understand what are their needs, what are they also able to process within their company, for example. So you need to give them the data that is also in a way understandable and usable for them. And we, for example, at EOMAP, we have we have different apps in which we present the data. So we do have our EOApp Aqua, for example, which is a solution that we offer our clients for the water quality sector. So we would upload the water quality data that is already quality controlled. And then the customer can just play around with the data. They have a nice map where they can see all the water bodies that they are tracking. They see on one glance if there is like one lake where you have high chlorophyll levels, for example, at one glance. You can also have like different graphs where they can just have like a baseline monitoring, basically see how it developed in the past and how it's changing now to understand the processes that are happening. So I think it is really key to not just have the data and like tell the people we can work with the data, but also understand and give the people the right data they need.
Yeah, I love that. I love the quit bragging about what you do. I was working on a project earlier this year, and it's like, you know, if I'm a farmer, my AI question is, do I plant my field today or not? Quit talking to me about AI, quit talking to me about pixels, quit talking to me about all that. It's like, because if it works, that's great, but if it doesn't work, I still have to farm today, one way or another. And I'd rather do that because of the solutions and the data products and algorithms and everything that we work on. But ultimately, you know, there's like, yeah, I don't care about the pixel, I care about the end result. Finish this out on this topic, Mo.
Yeah, and I'm glad you finally said AI. It took us 20 minutes because actually, I mean, that's what kind of we're tracking, and I'm tracking. You know, everybody seems to be using large language models in conversational AI in the world, and a lot of what we're tracking here and in the industry is people's curiosity and becoming in need of how does that intersect with Earth observation? When are we going to be able to start talking to our applications and asking for the analysis that we need? And so in our industry, you know, to actually get the answers you needed, you almost had to know the source. You had to know the upstream providers. You had to know who was in the industry. You had to know what they did, and you had to know about the technology. You know, for example, hyperspectral. If you if a hyperspectral data source came online, you had to know this could solve these problems. That means that our industry was kind of cornered into being expert-led, and that was a big barrier. Now, I think that AI and large language models applied to Earth observation data can shift the balance from upstream leading the way and deciding what pixels and what data we get, to now the downstream user saying, these are the problems I want to solve. Upstream providers, you need to react. And so we're trying to figure out, okay, what does that look like in practice? What does it look like in practice where the users, the people that are solving that have requirements trying to solve problems, are driving the demand for upstream data providers, whether or not they're satellite, drones, aerial, terrestrial. And this is the brave new world. This is where we have to go to expand our industry, because if a plain user on the street can't ask a question that tips an Earth observation satellite to make a collect, and then there's a analysis that comes to a decision, our industry will stay exactly the same size it is today, or shrink.
Yeah, I think that's a great point. And we made it almost halfway through the session before we got to AI, but here we are. So let's take a deep breath. I know it's top of mind for a lot of people is what impacts are you seeing on EO workflows around AI? What are sort of maybe the low-hanging fruit or things that are obvious to do? What are the things that you're hearing people talk about that we're not quite there yet or needs a little bit more work? And then also, I think equally important, what have you seen where it might just be out of reach for AI to, we'd like to say AI impacts everything. I mean, you can't watch a video, or you can't listen to a podcast without saying that. But I still think there are probably elements of chain of custody about deepfakes and things like that are going to require some sort of intervention. And I'm not seeing any obvious solution around automation or AI with that. But what impacts are you seeing on our actual workflows? Let's start with you this time, Alina, since you're a data analyst.
Yeah, I mean, the possibilities that we have through AI are very big, right? So we can do things that we couldn't do before. We have, for example, monitoring purposes. So we are able now, if we have integrate that maybe with some real-time downstreaming of data, and we have the possibility to use geospatial data to very quickly react to disasters, for example. We have an AI that can inform us something is going on, and it can inform us where is the main area of the catastrophe, where are places where we have to intervene, how can we get to the sites, things like that. So it's very powerful, but we also do have some risks, I would say. So we need to understand the biases that are within the models that we're using. So we need to understand what is the training data. We need transparency. We need to understand where does the data come from? Who is basically offering the AI? Is it just the big companies, like governments, who are feeding training data in the AI? Then it's kind of exclusive, right? So we need to democratize AI. We need to make it accessible for everybody, and we need to make sure that everybody can contribute to the models that we are using. So I think that is something that is very important to keep in mind. It's a great possibility, but it also bears certain risks. And excited to see where it's going.
Yeah, I'm very interested in that, democratizing the models. I think one of the things that I'm seeing is that the foundational models need quite a lot of fine-tuning right now around AI and things like that. But over time, one has to imagine that fine-tuning is iterated back into the foundational model. So if whatever you're doing is solely on the fine-tuning side, that there might be a shelf life to that, and you might need to pivot away. I'll come to you next, Max.
Yeah, I think what we have been seeing, so maybe 2 points. On one side, where is it already working particularly well? I think we have made first-hand experience with object detection, especially on good ortho data. Object detection is very quickly very, very powerful, and there was legacy companies that for 30 years developed object detection algorithms. I think the way that was approached previously to today is just a complete disruption. You can shelve that entire 30 years of R&D that went into it, and you can just start with the latest foundational model. And now I come to my second point. I think right now, if you're trying, there might be very large companies that can still do it, maybe on the Esri side, but for small to medium-sized companies, I think leveraging the foundational models, you get exceptionally good results. And to think that is going to be your competitive edge, I think object detection will get commoditized way faster than a lot of things we have been seeing. So you need to add some value on top of that, and then it can get really interesting. But pure object detection is a solved problem today in most cases. It's totally crazy how fast that changed from being a very protected thing only a few companies could do and had heavy investments into, to now you take an open source model and it's already pretty good. Last point maybe on that, I think for a long time it will need some human oversight to it. So it's never, these models are all not perfect, but if I can get 99% done and on 1% of my detections I still need to, or on 0.1% I still need to click yes or no, and as a human I can, and that again trains the algorithm further, that's already like a lot better than the completely manual process that people had to go through for a long time.
Yeah, it's sort of reminiscent of the early days of geocoding, where you were working and you could automate to a point, but there was a deteriorating function of time to value on that last 1 or 2%. I think that's a great point. I'll come back on this side to Bo, who kicked us off with AI.
Yeah, and so you asked about the lowest hanging fruit with AI. I mean, right now I think in our industry it's source selection, it's data selection, it's asking, using AI to ask what's the most appropriate data to solve this problem, and I think that's just a great start. Let's start there, because if AI can start recommending data sources to solve problems, then it can start building up knowledge about the problems we're solving, and then it potentially could suggest that we need to solve certain problems. And I'm trying to imagine a world that will happen probably relatively quickly, where we'll come in, sit at our desks, and AI will say, this is what you should work on today. I suggest you work on this today. We've had suggestion engines for many years, but let's turn them on to our geospatial projects. AI has the power to do that. AI, I completely agree with Max about the commoditization of object detection. It's happening. The models that we're seeing that are coming from Meta and Google are making it just amazingly easy to get high quality, high accuracy objects out of geospatial imagery. It's just revolutionary, and I think we can expect to see that pace in more assistive AI and agentic AI that will help us do our jobs. The last thing I want to say about AI is what you're alluding to about deepfakes and everything. This is a problem we have to solve. We absolutely have to solve the problem that people have confidence in imagery. I believe that right now there's still a high level of trust in geospatial imagery coming down. But we have to continue that trust, because I will scare you with the alternative, and the alternative is that we're back at film. You can't mess with film, but nobody who ever worked with film wants to go back to film. So we got to solve this problem.
Yeah, I think that's important. And we've heard now from two speakers say object detection, and it may feel like that happened overnight for the geospatial industry, but there was many decades of research that went into something called computer vision, and that's really the origins of this. And so you may hear it by different names, but they're talking about the same kinds of things. And Bo alluded to low-hanging fruit, and some of the things he's describing. Another way that I've come to think about that is AI is really good at solving tedious tasks. And if you can break what you're doing down into one or more tedious tasks, those might be the first things to look at for your AI. And if it looks like that's not a tedious task, then maybe that's not an early candidate for AI to tackle. But what are your thoughts, Simone?
I see other tasks that are, I'm looking at what our customers do, because we build the infrastructures where we basically serve data to people working with AI, etc. Mostly research, but sometimes also on the field. And one thing where I see AI is being helpful is, for example, everything that is related to real-time analysis, alerting, etc., etc. We are seeing being used, for example, for detecting anomalous behavior for ships and things like that. I think there is still need for, let's say, a human decision at the end. I wouldn't automate decision like sending a ship at sea to check what's going on. Well, that's probably still debatable. But anyway, early warnings, think about floods or things like that, because I mean the point is also trying to be more or proactive rather than reactive, because I mean we can already measure the level of a river and send an alert when it reaches a certain point, but sometimes it's too late, because if you send an alert when the river is at a certain point before people move, I mean everything is already flooded and you will get people dying. That's the problem. With AI, it's not just AI, but with everything together, also the computing power that we have, we can try to be more proactive. And I mean, instead of getting an alert when it's too late, you can get an alert previously. On these things, I see AI as part of, cloud computing, whatever. I mean, we're not just talking about AI in isolation. It's making already an impact. There is also a lot of hype, let's be honest, because every time I talk to customers, what do you do AI? What problem do you have? Then we'll discuss, I mean, if we need AI or not, because sometimes it's a computer vision problem, as you said, or it's a problem for which we already have the tools. It's not always, AI is not always the solution to everything. Okay, so, and then there are a lot of risks around AI that, I mean, that's probably a philosophical discussions that we need to take into account. I mean, privacy, lineage, I mean, what he was saying about deepfakes, etc. I mean, and we all see that already outside the geospatial world in normal life. I mean, everybody's using AI to respond emails written with AI. I know it's a joke, but it's the reality. You can see the emoticons, the double dash and everything. I immediately, even my accountant, I sent him an email last week and he answered me. I told him, it's ChatGPT or Gemini. He said, it's Gemini. Okay, that's okay.
That's fantastic. Finish us out on this topic, Will.
Yeah, so it's, I don't see the data flow coming out of low Earth orbit, or indeed the sort of low altitude economy getting smaller, yeah? And if we're gonna really put those pixels to work, we don't have enough people, we don't have enough eyes, we absolutely need to use the machines. I think to Max's point, I think we'll see a time in the near future where object detection of common objects is built into a pre-processing workflow. And with the metadata of an image, you'll have number of cars, number of trees, number of houses, blah, 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 blah. And that will become part of the metadata or stat catalog or whatever catalog we all agree on using, that will make the data AI enabled more so, because some of that basic data is built in. So you know what's in the image already before you even have to look at the pixels. And I think that becomes really interesting, because a lot of those processes are already done on ingestion into whatever computing environment you're using. So I see that being sort of a foundational change. So ingestion will have AI components built in, and then AI will become this insight layer on top. So the basics of computer vision will create this inventory, and then you'll be able to do the insight, which is always context dependent. And there's probably a human component to that, at least for a while, where we get to choose what it is that we want to figure out about our landscapes as they change. So I see a couple of different sort of injection points where traditional kind of machine learning, traditional AI, and then this more sort of Gen AI thing on top where it's a little bit more exploratory.
Yeah. There's a lot of exciting things in there. I know I've seen efforts where stoplights know whether or not accidents happened in the intersection on their own, yeah. And they already know who to call for for emergency services, or they can tell how traffic volumes are changing throughout the day and dynamically change timings yep. on stoplights and things like that. So a lot of practical use cases in those workflows using the computer vision and pre-populated yep. Metadata that you're describing. So that's some of our possibilities. We need to spend just a couple minutes, and I'll just open this up to anybody who wants to share their thoughts around risks and challenges. We touched on deepfakes, we've touched on automation, we've touched on the need for humans in the loop. Is that it? Are there other things that we need to be thinking about? Who wants to start us off?
Yeah, you didn't say like compute storage, which equal cost.
Yeah.
I mean, cost is a huge challenge still. I mean, especially people who are building foundational content, whether those are models or they're, data products. It's still very expensive to do that compute. I mean, even though most people are leveraging the cloud, which is the best use of those economics, it's still very expensive. The data is very heavy, which includes cost. I think that Will's onto something, and there is some pretty impressive work being done in this thing called embeddings, where that is trying to kind of reduce the amount of information coming down by pre-running models and embedding information in the data. That has the possibility to cut the workflow off, cut the data size down, reduce the cost. And but yeah, cost still a huge challenge.
Yeah, even adding to that, you start contemplating edge compute and things like that, and edge compute can be really nice, but then there's a maintenance cost to that too. That becomes something that has to be considered. Did you want to react to that, Will, or?
Well, yeah. I mean, I'm a Scotsman, so I think about cost. but it's yeah. I mean, it's going to be a consistent problem. Storage is always going to be a problem. We need to make more. But there's also another piece, which is, how many people in this room have data stored on an external hard drive somewhere that is not accessible? Like tons of, it's like the de facto workflow. And I would argue that the dominant design that we still use in the cloud is still, I want to move a piece of data from here to this computer, which is mine. And it's like, that's like what we always used to do with traditional computers. It's not how the cloud's supposed to work. So we're not supposed to move data across the network. We're supposed to send requests and get an answer back. And we need to start thinking about how to really use the cloud rather than pretend the cloud is just a bunch of computers and just absorb all that bandwidth for no reason whatsoever.
Yeah, Max.
Yeah, I would directly add to that point. I think my last edition is standards, and it fits here very well. I think the challenge we have right now between different clouds is exactly what you're saying. It's copy pasting from one cloud to the other, which is totally economically not viable. It's going to add way too much data. There's no true interoperability, right? It is more, yeah, you can send it over and then somebody does something to that data, but it's not mirrored back. And the problem to that is that we would have to agree, and hopefully we can, on standards. Because if we all use the same standards, then suddenly, yeah, Esri's and Wingtrust Cloud could easily talk to each other. As long as we have the same standards, they can pull our data, they have the same permissions, user profiles, all of these things, but it would need to be completely standardized, because that's also, I think, personal computers offline or on-premise, they were not even able to do this, like pointing to one other computer and getting it, except you were in a local network where you had the same standards because you're working in the same company with the same permission profiles, etc. So the cloud now technically enables it, but as long as we don't have the standards, it will be holding us back a lot. And I think that's the same to like any type of I love the idea of having metadata added early on to those models, but if we don't agree on standards, it's going to be worth nothing. And I think everybody agrees standards are great. It's just so hard to make them. So I throw out the question, how can we get better at this as an industry? Because that will propel all of us a lot faster forward.
You look like you might want to say something, Simone.
Something quick. Standards is like metadata. I mean, everybody talks about it, but everybody hates it. Let's be honest. No? Because every vendor wants to have its own solution end-to-end, so you are in it, you cannot leave it, and let's be honest. Okay? And the cloud providers are the same. Okay, once you tie your solution to a cloud provider, it's usually difficult to move it to another. And the thing about that saying about moving data, cloud providers, they know it very well because it's one of the most expensive things that you can do when you are in the cloud, if you move data around cloud. When you put it in, it's mostly free. As you try to get out, well, it's not that easy. And the risk about AI, there is one thing that, which is a little bit outside the geospatial world itself, but the impact they are having in terms of energy they need, if you think about it, this could be a risk. I don't know if climate change is still a thing nowadays, but I mean, scientists tend to think so, but I don't know. Anyway, so that is a risk, but it might become also an opportunity because there is a huge amount of money behind it. And that is a word, if you have worked with it, which is super legacy. So they have been challenged with, the ability to transfer so much energy or to build these data centers, which requires a lot of energy. The cooling, we are discussing about reusing the heat to actually hit entire cities. So it's a risk, but it might become also an opportunity to create innovation and maybe work for geospatial companies as well. Because I mean, in the end, we are all companies, so that's one of the main things for us, no?
Yeah, no, I think that's right, and I agree with you, Max. On there needs to be a common language. One of the words I'm hearing a lot more is on interoperability. Like, we may not have to speak exactly the same language, but we have to be able to communicate. And whether that's through APIs, if that's through a common core set of metadata or standards or something like that, I think we've got some great organizations in the geospatial industry that address things like that, and they need to be supported as those needs unfold, because I think, it can go off the rails quite easily. And I wanted to come back to Bo's point before turning it over to you, Alina, is I'm reminded of a talk I said at JPL almost 20 years ago now, and they said in 2006 that the world passed this point where it was more likely that the data collected would be used for something other than its original purpose, and that they knew definitively you can't store all the data. So given that model, how do you decide what to keep and why? Because you don't know how it's going to be used in the future, but you also know you can't store it all. And there are lots of different approaches to that, including in terms of it being cost prohibitive and the hard drive problem and all of this, that some projects decided we aren't going to try to keep it, that it would actually be cheaper for us to recollect all that imagery again in the future than it would be the cost of ownership of maintaining it over a long arc of time, which is not a solution that I think we would prefer, or one that I hear talked about widely, but it is something that different organizations have thought about as a solution, so to speak, which isn't really a solution, but interesting thoughts. Can you finish us out on this one, Alina?
Sure, I think that's actually an interesting thought that you're putting out there. I think one option also to reduce the data that's been talked about is also to have AI already on the satellite at the sensor to just get the data to the users that they need. So for example, if you're detecting wildfires, you only get the spectral band information that you need and not everything that the hyperspectral sensor can collect. And again, just looking at the use case of the data and how the data is being used, maybe there could also be a way to deal with the massive amount of data that we are capturing, just trying to be selective of what we actually then get down to us and actually have to store.
No, I think that's a great point. So get what you need, not everything.
Can I add one thing to
Sure.
that, though? So one of the big challenges that this industry will continue to have, unless something changes, is the actual regulations around collection, especially satellite collection. That will drive, no matter how good we get at creating derivatives at source or reducing the data, there are requirements still, government requirements that say you have to keep the original data. And I mean that. So part of the solution will be also a regulatory change. It says, hey, I don't need to store 100 petabytes of cloudy imagery, from space. I get to make those decisions, but for now, everything that is collected has to be maintained at some level. So that's a big problem. But I will also say I've seen those talks too. I've seen 3 talks over the last 20 years that said the cloud will fill, and this was the number, and the number keeps moving.
Yeah.
So we do keep innovating in storage.
Yeah.
So there's some hope.
But to Simone's point, at what expense from the energy profile, and it's telling when you have tech companies buying and restarting old nuclear plants and things like that. So as we're sort of closing out here, let's bring it back to the future, and bring it back to actual sort of use and commercialization of EO data. If we're here back in Frankfurt in 2 years at INTERGEO and we're on this panel again, what is it that you imagine has happened between now and then Are we talking about the same topics, or is there going to be a completely different conversation? And what would have led up to that conversation? Anybody can start us off.
I think, well, I would love for our community to have done a better job of harmonization between data products. I think the analysis-ready data community, I think CEOs and NASA are having a pretty good stab at that. If that gets resolved, then like that unlocks a bit of an AI future. If we resolve that, then we can get to a place where business models start becoming a little bit more consumer-oriented. And then I think Earth observation-based derivatives can sort of leak out into consumer space. Not space, consumer sector, as we say. It's getting confusing. And then I think there are some really interesting applications that could genuinely be put to work. And I would love to see, part of our organizational mission is how do we put all those pixels to use? Because I think there's so many pixels that get captured and never looked at by a human. That seems sad. We should put that to work. We should change that. And how do we get more geospatial technology into the hands of the everyday person? I think most people interact with geospatial technology in terms of navigation and weather. And we've got to do a better job of that. There's tons of other use cases. So let's reduce the cost so it's not just experts that get to use the technology and then push it out to as many people as possible. And then this show will become 3 or 4 times the size by nature.
Yeah, I think that's a great point. And another way I think about that sometimes is that EO right now is more of a vertical market, but if you can turn that into a horizontal market.
Well, I think geospatial is a deep horizontal. Like AI, I think geospatial is part of almost every single business question, but it's not the whole part.
Right.
Yeah? So how do you sell that component as opposed to selling the whole stack?
Yeah. Go ahead.
I will be honest, I don't think we are the right audience to answer that question, because everybody here is B2B or B2G, okay? And the big revolution that touched the masses has always come from companies that sell to the masses. I mean, when I started, at a certain point, something called Google Earth happened, and everybody was asking me, can you do something similar? All the time, okay? Then it was Google Maps, Google Earth. So I don't know if any of us can, at least this is true for myself, I don't think I can answer that question. But, and I don't even think INTERGEO will be much different in 2 years, to be honest. But I'm hoping that the dust will settle on AI, so it will be more clear for people what you can really do and what you cannot. Maybe we won't have another 2000 bubble like we had in the 2000, hopefully, because that would be bad for everybody, but that's another topic. And yeah, I mean, one quick thing about the data storage. It's true that we are storing too much, but what I see from, again, customers like cities, et cetera, they make these acquisitions, okay? I'll give you a very simple example. You make an acquisition because you want to create a 3D mesh, okay? And nowadays it's mostly 3D tiles. They deliver you the 3D tiles. You use it in 6 months because that's the reality. Nobody uses the data immediately. You touch the 3D tiles, oh, I need to reprocess it. Yeah, but I need the original data. You look at the contract, you didn't have the original data in the contract, so you cannot do it. What do you do? Another acquisition? So I see many companies that bought, in Europe we had this huge effort at European level after the COVID, the recovery fund, etc. So we had to spend these funds quickly. So everybody's starting to buy things that were ready quickly. And then they thought afterwards what to do. And we know a few cities that have the products, but not the data, if you see my point. So storing the data is a problem, but it's also something that you want to do for the future. Maybe we should automatically delete that after a while if you don't use it. That's what I do inside Geosolutions. If you don't use it in a while, I will delete it. It's too late. Okay, but I mean, it's a risk to not having the original data.
Yeah, that's how we used to clean up the storage when I was at the university, is you delete it and see if anybody calls
if
the
nobody
phone.
complains, you don't need it.
Look like you might be ready, Bo.
Yeah, I mean, what I'm hoping in 2 years, you said 2 years, is that come to this conference and the people that serve downstream users, actual users of Earth observation data, are I start to see more conversational interfaces in their applications, in their tooling. So if that starts to happen, that starts to drive this industry more towards a B2C world, because the B2C world, that's the way they want to interact with everything, or that's the way they're going to interact with everything. So if we can start showing enterprise users, B2B, B2G users, that you could do the conversation, that's, I think, the first step. And I think it starts with people here. And I agree, if we can nail that, we can start growing the industry and make this conference and other geospatial conferences a lot bigger, because there'll be more applications, because there'll be more downstream users.
Perfect. Lena?
Yeah, I agree with what Bo was saying. For example, like using what Esri is doing with the GeoAI, for example, that it's like a great start, right? To using also like something like the large language models to get just geospatial data into the masses, to make it for us as geodata experts, but also non-experts, easier to interact with the data and use the data. And I think that is something that could be very powerful in the future. And also, if you think about the different applications of AI, talking about disaster risk response, for example, it's important that not only us as the geodata experts put in information in the models, but also the people who are experts in the subject matters, right? People who work in disaster response. So making data, geospatial data, accessible for those kind of people, and integrating those kind of people in our processes of growing our AI models is something that I would hope to see in the near future.
Yeah, I think that's super important, the domain expertise of what I'm looking at and why. Max?
Yeah, I can only second what was already said before and re-emphasize it is important that we are able to democratize and to open up geospatial data that can be so powerful to manage our planet in an easier and more sustainable and more efficient way. But we need to enable more people to be able to do that. And hopefully we can do that with the help of AI and technology in general. The other thing that I would be excited about is seeing in the next 2 years more real-time or closer to real-time applications and more of those predictive models that we were talking about. And I think part of it is we need very up-to-date, good quality and very timely data. And I think there's more to be happening in the broader, I come from the robotics background, in the robotics segment where edge computing and doing things on the edge will get much more prevalent or mainstream in our industry, and that will ideally give you insights directly from that satellite or from the drone, and you don't have to go all the steps from data to information to insights and then to action, because that will always take time. So I'm excited to see a shorter time to value for customers and for more customers to manage our planet in a better way.
Thanks. Well, I was looking at our time, and we're about out here, probably not enough to dive into a whole nother topic, but I will give the panel one opportunity if there's a burning thought, a burning question that you've been wrestling with that we haven't covered yet, and you want to get that out there. Here's your chance. So, anyone want to share any final thoughts? They said it all. So let's leave it there, and if you would join me in thanking our panelists for their insights today during this session.
Thank you.
Thanks.
Thank you.
Thank you all.